If you've watched my channel for long, you know what a big fan I am of this clamp meter. And judging from how many views that I've been getting, you are a fan of it as well. So this is one of my most popular videos, and today I'm going to show you a couple more tricks and features that will help you use this meter even better. So stick around. I'm Steve, this is RV Squared. Thank you for watching. Now, the ideal clamp meter that I've shown in the past is an invaluable tool for diagnosing and monitoring your current, basically your amperage. And it's great in situations in which you need to find out how much flow is going into your coach. Now, there's a couple drawbacks on it. First of all, here you see this is a closed, insulated pigtail, which does you no good. You cannot clamp around all three legs. It's known that these clamp meters aren't super accurate down to anything maybe under 5 amps. So what they have out there is called a splitter. This is a 10-to-1 splitter. Now the advantage to this is when you put this splitter in line, first of all, it gives you a really easy way to put your jaws through without having to develop a pigtail like I've done in the past, and I'll show you again in a couple minutes. The other thing too is this actual loop in here causes a 10-fold increase in your meter reading. The nice thing about having a 10x multiple is when you start dropping down into maybe 1 or 2 amps, instead of looking at your meter and it's showing only 1 amp, it'll actually show 10. And so as it starts dropping down to 0.9, 0.8, 0.7, it'll show 70, 80, 90, and you just divide that figure by 10, and then you get an accurate amperage. Now, one thing, in case you're not electricians out there, you have to understand, this is an AC line. You have to make sure that your setting on your clamp meter is set to not the one with pluses and minuses, because that's for DC, and it'll show you in the display DC. You need to make sure that it's on alternating current, which is the wavy line. That's the universal symbol for alternating current, or AC. And down here, you'll see that the meter is set to AC. And that's really all you need to do to turn this meter on. Now, depending on the meter, I'm going to show you something else in here that you should be aware of, because what it's going to do is it's going to change the polarity of the current. So the current's designed to go through the jaws in the direction of this arrow. In this case, it goes away from my display. Now, that's not a big deal, because normally if you see your display say minus 10 amps, it's really not going to make much difference. But in a minute, I'm going to show you a couple tricks that negative sign is going to make a difference. I'm doing it in here because of a couple reasons. I want to show you the real world example of how I use my charging system as well as this clamp meter, and I also don't want to touch my coach, because I want it to be a real example of what the coach looks like after it's been parked for a while. So here's the scenario. I'm connected to 110. I do not have 50 amp here. I've split my 110 into 2 legs. I have lit power cords that enable me to monitor them at all times 24/7 with my security camera. That way, anytime I want, I can log in and I can see that these extension cords are still charged with energy. That doesn't give me the ability to actually monitor how much is going in the coach. However, with this Victron charger, you'll notice it's tilted up a little bit here, that I can tell where these LED lights are lit. So I can tell at a glance whether my rig is at float, absorbed charge, or bulk. And it gives me like a rough idea of what the state of charging is on my coach. If I want the best of the actual current that's in the coach, I can log into my Rosie, read the actual DC charge as well as the amps that are flowing inside the coach through the inverter. But let's say, for example, I come to the coach and it's been a while, and I want to observe how my batteries are doing. Now, I've already walked in and seen that my batteries are in great shape. The chassis are sitting at about 14 plus. My house batteries are around 13 volts. So everything's in good shape. The refrigerator's off, everything's off. The only thing that's running on a constant basis is the compressor, and that doesn't go but every, I don't know, 45 minutes. But you know, it only runs for about 15 seconds when it does. So there's really no current draw other than the electronics on the rig, which there is some parasitic draw on these coaches, but I really don't know how much draw that is. So in this case, I'm going to actually monitor from the plug coming to my coach and see how much energy is being pushed into the actual charger, how much energy is from that charger into my batteries, and then I want to monitor my batteries into the coach. So I'm going to just kind of break this down. I'm going to show you how incredibly useful this clamp meter is. So let's get started. Here's the lit extension cord, and you can see this little pigtail. It's a cheap, you know, 18-inch pigtail, and I've carefully stripped off the outer insulation from that to expose the 3 conductors. Now, as I said, under low flow or low amperage situations, these clamp meters start to diminish their sensitivity, if you will, or I should say they start to diminish their accuracy, if you will. And some people have written in, and I appreciate the comments, that hey, you know, it helps to use a splitter, and that is true. Normally I've just been spoiled. There's enough current 6 or 8 amps in here. I don't really have to worry about that 1 or 2 amp level. It's normally up in the 6 amp range, and we're going to show you that right now. So step 1, I'm monitoring AC. I'm monitoring the 110 AC current. I need to make sure my clamp meter is set to alternating current. Remember the wavy line. So I'm going to verify that. It is in fact set, and I'm just going to make sure that my clamp meter is around the conductor. And realistically speaking, it doesn't matter whether you're going to the neutral or the hot lead. You can't clamp the green because the green is the ground and it'll show you 0. So you can clamp black or the white, which is the line or the neutral. They're both going to read the same. All right. So right now I can see that I am running 5.5 amps. Just to show you, I'm going to check the black lead, and it's exactly the same, 5.5 amps. And I'm going to turn the meter around, and it shows you, I'm going to turn on the light, and you can see that it's still 5.5 amps because there is no polarity, if you will, on alternating current. The trick I'm going to show you in a little bit with the negative, in terms of which way your meter is turned, isn't important on the AC line as it is on your battery. So let's make an example from this. Keep in mind, my meter says 5.5 amps. Now watch what happens when I put this splitter in line. I'm not going to do anything except put the splitter in line. All right. Nothing at all has changed. It says right now, well, since I recharged the Victron charger, it's bumped up to just under 6, but let's call it 5.9. And I'm going to show you, I'm going to just do one simple thing. I'm going to remove it from the actual line. I'm going to put it around the splitter. So you see here, it says 5.5 here, but over here it says 55. 55, I divide it by 10, and you get 5.5. So again, with 5 amps, it's pretty accurate. So I'm really not worried about it. But when you start getting in the 1 or 2 amps or even below 1 amp, to help the clamp meter be more sensitive and more accurate for you, use that 10-to-1 splitter. The links for those products will be in the description below. Make sure that if you're watching on YouTube on your like your iOS devices, a lot of you can't find those links. Well, if you tap on that title line, it'll pivot that whole box open, and you'll be able to see the description for the video below. So that's how I monitor the actual AC current going up to my charger. And you can see how valuable that split pigtail I have is. But for those of you that don't want to take apart a pigtail, for the same amount of money, you can buy one of these splitters. And realistically speaking, you know, it goes into your toolkit, and you can take that everywhere you want. They do sell 1-to-1 splitters. So if you wanted to get one that it was a true open loop splitter like this, you don't have to do any shredding of a pigtail at all. It'll go in there, it'll read a true reading. But for the intents and purposes that we're using it for, a 10-to-1 splitter on these low current situations really works out great. Let's get on to the next part. I'm sorry it's a little dark, but hopefully you'll be able to get the gist of what I'm saying. And I'm going to describe to you how I've got my charger connected so you can kind of follow along. So from my Victron, there's 2 6-gauge wires, positive and negative. They go into an Anderson plug. And that Anderson plug pigtails onto my top bank of batteries. I have 6 8D batteries, the top bank and the bottom bank. Behind the panel, they're actually merged together. So they have separate high gauge cable feeds into the coach to be merged behind the panel. That's just the way Newell wires these. So I depend on my feed going into the top bank and then reversing and back feeding to basically keep the bottom bank charged up as well. So they're all basically tied together in parallel, if you will. What I want to do right now is I want to monitor how much energy is coming out of the Victron charger. Now remember, it's polarized, it's DC current, positive and negative. Red for positive, black for negative. So that means I need to switch my clamp meter over to DC. So I'm going to use the symbol that has the solid bar with a dash underneath it on the A, which is amperage of direct current. Now, this is where the direction of this meter is going to come into play. When the current is going into your battery bank, you're going to make sure that the arrow is facing in the direction of the current. Let's just verify that. I'm going to turn this light back on, and let's see what we've got. 30 amps. So that charger is maxed out. 30 amps, and if you want to double check, watch what happens. I'm going to not turn the meter over. I'm going to put it on the negative side, and now it says minus 31 amps. So it's exactly as I expect. Now that I've got 2 different banks of batteries here, I actually want to monitor the individual banks. The top bank is here, the bottom bank is here. Let's go ahead and just, out of curiosity, let's check the top bank. Again, check your direction. In this case, my display is going to be upside down, but it's not a big deal. Okay, so I'm looking to see how much current is being pushed into the coach from my top bank of batteries. And right now, I've got 28.7 amps going in to the coach from that top bank. Now, I'm going to double check that. I'm going to go right over to the negative side, and what's going to happen there should be the same amount, but a negative figure, and in fact is minus 28.5. So that's exactly what I expect. Now here's the interesting thing. Because my batteries are being charged from the top bank, and I'm relying on it to backfeed, I've noticed that my lower bank of batteries don't show that same amount of current draw. But let's go ahead and double check it. Again, polarity makes a big difference here, so I'm going to check my positive lead of my lower bank of batteries, and I don't know if you can see it. Maybe you can. I'm going to move this around just a little bit. If you can see that, it does exactly what I expected. It's pulling 1.5, 1.6 amps out of that connection, the coach, into that bottom bank. So if you think about it, the 2 banks are actually kind of equalizing themselves. This top bank is giving off energy, and it's going behind the panel, and it's coming back down to this bottom bank. And I'm going to back that up by moving over here to the negative side. And as expected, the negative becomes positive on that side because it's pulling energy out of the coach, and it's at 1.9. So these 2 are exactly balanced, the positive and negative sides. But what's interesting, what I want to show you, is that verifies the fact that the energy is coming in to the top bank, and it's supplying that top bank is giving off its energy, and it's backflowing down into the bottom bank. So it's just an invaluable tool. You would really not have any other way to examine your current flow. And there's all sorts of different things that I can do in here to back all that up. For example, I can turn off both of my inverter breakers up here, and I can actually do a master disconnect, and then all energy will completely stop. Okay, so now we've verified the charger's actually working. We've verified there's 30 amps going in. We're verifying that the top bank of battery is in fact receiving its charge, and it's giving off energy to the bottom bank. So now let's go ahead and disconnect the charger altogether and see what happens to our flow from the batteries into the coach. There's the Anderson Quick Connect. It's a small SB50. These things are just the bomb. You can't mess them up. They're polarized, so you just go in there blindly and just connect these together. They're just the greatest. And I bought these from Battery Cables USA, and you can get them custom configured, or you can buy preset pigtails. It's a great company. So I'll drop that link to that company below as well. Okay, I'm just going to let it park here a second, let things equalize, and we're going to see a lot less current going because there's no draw in the coach right now. Everything's turned off, so I shouldn't see much more than what would be deemed as parasitic draw or residual draw. There's no compressor running, there's no water pump running. All I've got is the electronics, the router and a couple gateways, some switches, you know, Apple TVs, and shouldn't have much more than that. All right, so let's go ahead and turn our light back on, and let's meter our top bank. Remember that top bank was 30 amps, and right now it's at 14 amps, 14.8 amps, and let's meter the bottom bank. The bottom bank is at 12 amps. So that tells me that these two batteries are putting out a considerable amount of energy into the coach. So I'll watch that for the next little bit, and I'll determine whether that's normal or not. After a while, it may calm down. I might not see as much energy going into the coach. After I let things calm down a little bit and let the coach equalize, if you will, I also go inside and check my silverleaf panel. So let's go do that. Now, anytime I look at current flow outside the coach and I see something abnormal or something normal, I will always back it up. I'll come into the silverleaf panel and I will double check my DC flow at the panel here to make sure that they match. So let's take a look at that. So here you see my batteries are at 12.9 and I have right now 0 amps. So I'm flowing basically no energy into my inverters, and that's what I like to see. Okay, now that I've gone inside and I've seen that my silverleaf is putting out basically 0 amp draws, and I'm going to double check my batteries to see what they look like right now. And if it has anything significant, I will address that with the next steps. All right, this lower bank is 13.6 and the upper bank is at 14. So for some reason, the batteries are giving off a lot more energy than what I would expect, especially when my inverters inside are reading 0, but yet there's basically 14 amps of current going out of my batteries. Now, remember that you've got DC and AC current, so you want to be careful that you don't cross those two. You know, you might see several amps coming off of your inverters at the AC level, but you've got you might see 30 or 40 or 50 amps coming off of your DCs. That's okay because it converts. It takes more amperage to convert through an inverter into 1 amp, so it's not a 1-to-1 ratio. The quick math, as I've explained in some of my other videos, is I just divide it by 10. So for example, if you've got, let's just make it easy math. If I've got 60 amps of DC flow, I know that should be about 6 amps on the AC side. And conversely, if I'm looking at my inverters, you know, or my shoreline for that matter, putting out, you know, 10 amps or 20 amps of 110, I know that that converts to about, you know, 200 amps on the DC side. So you can gobble up the energy in your batteries really quickly with a fairly low number if you're just using strict AC current. I'm still wondering why these are putting out more than maybe just a couple. So what I'm going to do is I'm going to double check. I'm going to turn everything off, my lights. I've got a couple outside lights, and I am going to actually turn these inverters off, and let's come back and see what they look like after I do that. I've made sure that everything's basically off inside the coach. I'm showing 0 amps on the silverleaf, and I'm just going to do one quick test here. Yep, I'm still running 12 amps. So let's go ahead and shut off first inverter, and let's see what happens. 13, and about 13. I'm going to shut off the second inverter, and it's drifting down to 4.9 and 5. So with the inverters shut off, the current is drifting down. Give it a couple more seconds here to stabilize. 5 amps draw. Let me just reverse my meter around just to double check things. Yeah, it's the same. Sitting right at 475 to 5. So let's go ahead, and now you may not be able to see it. I'm showing the flashlight back there, but here's the master battery disconnect. And I'm actually going to leave my meter connected as I flip that switch over, and boom, it's now down to 0. Both these lines should be at 0. And that's what's expected, because that's a hard disconnect. So if you ever had an emergency, God forbid a fire, anything like that, electrical short, this kills all battery connections behind the panel back there from the battery to downstream, which would be going to the inverter. So it actually physically disconnects the batteries from the coach, so to speak. So the breakers are strictly supplying the individual inverters. This master disconnect actually shuts the battery cables off, a hard disconnect right behind the panel. There's also that same disconnect in the engine bay for the chassis batteries. So if you ever have an emergency, it's the first thing you do. Flip that master disconnect. Don't worry about the breakers, just flip that master disconnect. That's a rotary dial. So basically, what does this do? This is just basically verifying that I've got a normal current draw into the coach. And I can reverse the order by turning the disconnect back on. And I'm going to bring my inverters back online. Right now we're at 12.2 and 13.3. So that basically tells us that those inverters themselves are drawing power out. And in this case, it's quite clear the power, according to Silverleaf, is not going anywhere. So you can deduce the fact that there's some energy waste in those inverters. And sometimes you might have other things on that you don't know about. A battery charger, the way Newell wires things in, it may be before that actual panel shows any reading. It really all should be downstream of that Silverleaf panel, but in this case, it obviously is not, because I've got frank current draw coming out of my batteries right here. And this is why I want to tell you how important having a clamp meter is, because you could be going on complete misinformation if you'd be looking at the Silverleaf panel, or for those of you that have an Intrepid display, it's the same thing. If you're looking at that and things aren't making sense, you need one of these. So I highly encourage you to get both the clamp meter. You can get them on Amazon. I got this one actually on sale at Lowe's. I highly encourage you to get this one here. They have a special name for this, Easy View or something like that. But when you have just the display in the front, I guarantee you're going to regret it, because when you have a clamp meter in here, how would you read that display without knocking your head or getting in some ridiculous contortive mess? Whereas this, I just look at this end, it just makes that clamp meter all that much more usable. So get the one that has the Easy Vision display at the base of it, and you might as well order up one of these 10-to-1 splitters. This one is from Southwire, which you've heard of before. They're fairly big in the electrical supply industry. And I hope you find this video useful as well. So thank you for watching. As always, make sure you like, and make sure, if you haven't already, to subscribe. I appreciate you watching very much. I love hearing those comments, and I hope you continue to watch in the future. Let me know if there's anything else you'd like to see. So safe travels and take care. Bye-bye.